Students will be able to graph a polynomial. In exercises 1 through 10, determine which functions are polynomial functions. For those that are, identify the degree. This is a polynomial, so the degree is 3. Number 2, that's a polynomial. The degree is 4. There's nothing wrong with any of this. The degree is 5. Nothing wrong here. Degree is 7. We got a problem with this one. We can't have variables in the denominator. So this is not a polynomial. Same thing over here. Not a polynomial. We can't have variables in the denominator. There's a problem with this one. This is not a polynomial. So no fractional powers. Not a polynomial. Same thing with number 8. Not a polynomial. This one we have a variable in the denominator. Not a polynomial. This one's fine actually because there is a denominator, but it's not a variable. So we have 1/3 x squared plus 7/3. That's a parabola. The degree or the highest power is 2. Use the leading coefficient test to determine the end behavior of the graph of the polynomial function. Since the highest power, the leading term, the 5 is positive, 3 is odd, so this will act like an x to the 3rd. This one is positive, but the power is even. This will act like an x squared on the ends. Now this one down here on number 23, negative 5 is negative, of course. 4 is even, so it will act like a negative x squared on the ends. Use the intermediate value theorem to show that each polynomial has a real zero between the given integers. For number 33, when we find f of 1, that's 1 to the 3rd is 1, minus 1 minus 1, that's negative 1, which is less than 0. So this point is below the x-axis. F of 2 is 8 minus 2 minus 1. 6 minus 1 is 5. That's above the x-axis. So this polynomial, this nice smooth curve, went from below the x-axis to above the x-axis. So it must have crossed the x-axis somewhere. The intermediate value theorem guarantees a zero between 1 and 2. Graph f of x equals that. The ratio between these coefficients is 1 to 1. So 1 to 1 here, and then if you divide these coefficients by negative 4, this is also 1 to 1. Now when that happens, we can factor by grouping to first find the zeros. We're going to find the zeros. The zero is x squared times x plus 1 minus 4 times x plus 1. We're taking out an x squared. 0 equals x squared minus 4, x plus 1. So this is x plus 2, x minus 2, and then x plus 1. So the zeros are plus or minus 2 and negative 1. So plus or minus 2, negative 1 is also a 0. Now if we look at the ending behavior, an x to the 3rd on the ends acts like this. Now we need some points. We need f of negative 3/2, which is negative 1.5. We need f of 0 and f of 1. So negative 3/2, and I'm going to plug it into the factored form. I think I'll plug it in right here. So negative 3/2 plus 2 is negative 3/2 plus 4/2. That's a half. Negative 3/2 minus 4/2 is what? Negative 7/2. And then negative 3/2 plus 2/2 is negative 1/2. So 7/8. So this is, we have the point negative 3/2, 7/8. When we plug 0 in, I like plugging 0 in here because it's just negative 4. And then 1, doesn't really matter which one we plug it into. 1 plus 2 is 3. 1 minus 2 is negative 1. 1 plus 1 is 2, negative 6. So negative 3/2 is 7/8. 0 is negative 4. And 1 is negative 6 down here. So they're all cut throughs because all of these zeros counted one time. So there's the graph. This is an odd function, so we're going to try to take advantage of the fact that this is symmetric over the origin. All the powers are odd. This is an odd function. So let's find the zeros. This factors into 3 and 2 for the 6. And then minus x squared here and plus x squared on this one. So x is equal to 0. This doesn't have any zeros. You can't square a number and the result be negative 3, so there's no zeros for this one. The zeros are imaginary. Here, 2 minus x squared equal to 0. There, x is plus or minus square root of 2, which is approximately 1.4. So we wouldn't give you this without having a calculator, so the one on a quiz or the test that we have is going to be a little nicer than square roots. So 0 is a 0, and it counts once. And so everything's counting once. Square root of 2 is about 1.4. Negative square root of 2 is about negative 1.4. So let's get, that's step 1, zeros. Second step, ending behavior. Well, this is a negative x to the 5th. So it'll act like a negative x to the 3rd on the ends. This is what negative x to the 3rd looks like. So 3, we got to fill in some points. And we need, well, we really just need to fill in 1 comma something, then I'll use symmetry. Let's plug it in, I don't know, right here. The original wouldn't be bad for 1. 6 minus 1 minus 1. So 4. So 1, 4. 1, 4. And since this is odd, there's symmetry through the origin. So through the origin, there's symmetry. So cut through, all of them are cut through. So something like that. This is an even function, so we'll take advantage of the fact that there's symmetry over the x-axis. Let's step 1. Let's get the zeros. So I can factor out an x squared, negative x squared plus 4. So x is equal to 0, but has a multiplicity of 2. Negative x squared plus 4 equal to 0. So x squared is equal to 4, because we minus 4 divided by negative 1. X equals plus or minus 2. So 2 and negative 2 and 0. And 0 is going to be a bounce. Now this is a negative x to the 4th, so it'll act like a negative x squared on the ends. So that's part 2, ending behavior. Part 3, fill in any integer values or at least one value in between the zeros. Again, I can plug in 1, and we get negative 1 plus 4 is 3. Now this has symmetry over the y-axis, so there's the point that would be symmetrical. And 0, remember 0 is a bounce, and the other 2 only counted once, so they're a cut through. So there's the graph of that one. Graph f of x equals all of that. So 1, the zeros. X equals 2 with a multiplicity of 2. X equals negative 4. X equals 1. So 2 with a multiplicity of 2, negative 4, and 1. And then now we need the second part is ending behavior. Well, this would be an x squared if we multiply it all out. X squared times another x is x to the 3rd. That's going to be a positive x to the 4th. So on the ends, it acts like a positive x to the 4th, which acts like a positive squared. Now we need to fill in points. So negative 3, negative 2, negative 1, 0, and we need 1.5 or 3 halves. So negative 3, we're going to plug it in there. So if negative 5 squared is 25 times 1 times negative 4. So negative 100. We're going to have to change. We can't go by ones on the y's now. Negative 2 would be 16 times 2 times negative 3. So negative 96. All right, negative 3 squared is 9 times 3 times negative 2. That's a negative 54. 0 is, let's see, negative 2 squared. Negative 2 squared is 4 times negative 1, so negative 16. Now 3 halves, let's see, 3 halves minus 8 halves is negative 5 halves squared, so 25 fourths. 3 halves plus, oh no, wait a minute. That's not right. Let's see, 3 halves minus it's going to be 4 halves. 3 halves minus 4 halves is 1 half. So when we square that, it's 1/4. 3 halves plus 8 halves, there's 11 halves. And then 3 halves minus 2 halves is 1 half. So 11/16. 11/16. All right, well, we got to go by tens to fit this in. So we'll make that -10. So -100 is down here. -96 is somewhere about right there. -54. -16. And 11/16 is almost 1, something like that. So we're down here. It comes up like this and bounces off the 2. See, the 2 counted twice, so that's where it bounces. The -4 and the 1 is going to cut through because those only counted 1 time. They counted an odd amount of times.